following identity, and it gives me sine of 137 degrees divided by cos of 133 degrees. Okay, so remember our aim with trigonometry is to simplify this. If it's less than 360 but still greater than 90, we need to use the reduction formula. Okay, so let's apply it. Let's say reduce this to something less than 90. Sine 137 happens to be in the second quadrant. So in the second quadrant, sine is positive. So that's going to be over there. Okay, so that's going to be positive sine, which I don't need to indicate the positive. I can just say it's sine. I don't know what's happening over here. That's going to be sine of 137. So we solve for theta, and that's going to be the given angle 137 is equal to 180 degrees minus theta, right? So that's going to give us that theta is equal to 180 minus 137 is going to be 43. Okay, and that's going to be sine of 43 degrees. Okay, and that was given by theta equals 180 minus 137, and that result of 43 degrees, that gets put into this over here. All divided by cos of 133. Now cos 133 still lies in the second quadrant, and only sine is positive over there. So this has to be negative cos, and that's going to be 133, which has to be 47. Right. And how did I get that? I said 133 is equal to 180 minus theta, and I solve for theta. That's going to give me 180 minus 133, and that's going to be 47 degrees. Right. And that's negative cos of 47 degrees. Now, very importantly, when you add 43 and 47, you get a total of 90. And when we have sine and cos co-ratios of one another, whereby they equal 90, when we add these two arguments or these parameters together, this cancels out with this, right? Right? And so now that leaves me with 1 over negative 1, and my answer is just negative 1. Okay. Remember, how did I show that these two are equivalent? Well, sine of 43 degrees is equal to cos of 47 degrees, right? In the same way that sine of 30 is equal to cos of 60. In the exact same way that cos of 10 is equal to sine of 80 degrees, right? Because they sum up to 90. And that's how I've solved this over here.